Welcome to our Design Day video for Project 26004, the AI Oral Board Simulator.
Okay, now we're going to introduce the team. I'm Beckham Davis. I'm a systems engineer.
My name is Daryl Izola. I'm a biomedical engineer.
My name is Parker Gus. I'm a biomedical engineer.
My name is Jonah Camacho. I'm a software engineer.
I'm Nick Brown, electrical and computer engineering.
My name is Nicholas Lilliman. I am a software engineer.
And these are our stakeholders. First, we have Cecilia Gossler, who is our academic mentor. And secondly, Dr. Eric Peterson, who is a trauma and critical care surgeon and aerospace medicine fellow. We also have an extensive medical team to ensure the accuracy of our medical data.
Before a physician is certified to perform life-saving surgery, they must first pass an oral board examination. During this exam, the physician is presented with a real-world scenario, and they must verbally explain their process for diagnosing the problem and performing the surgical procedure.
Simulating this exam is a pain point for many young physicians. It requires access to a physician with expert knowledge of numerous medical scenarios. It also requires a large time commitment from that person, as a real oral board exam is administered over 3 30-minute sessions.
Our solution, an AI-driven tool that simulates surgical oral board examinations, providing an affordable and accessible learning experience.
The goal of this project is to develop an AI-driven tool that simulates oral board-style examinations for surgical residents and space medicine fellows. The tool will allow users to engage in an interactive case-based scenario where they can demonstrate their clinical reasoning, decision-making, and communication skills, which are all key competencies required for success in medical training, practice, and deep space cognitive skill maintenance.
Now we'll be presenting our major system requirements. These are all the requirements that have been derived from instruction from our sponsors, discussion with our mentors, and discussion as a team as well. For the first system requirement, we'll start with the user interface. The system shall provide a graphical user interface that enables users to navigate options and interact with the tool over the internet.
We purchased a domain and deployed our code on AWS, so I can just pull it up here on Google.
Second, we have our mode selection. The system shall provide 3 operational modes. We have the mock exam, the tutor mode, and the just-in-time training mode.
Here we have our 3 operational modes along with descriptions. This way the user can select exactly how they want to practice.
And for our third system requirement, we have case selection, where our system shall allow users to select a medical case and initiate a mock exam session.
After selecting the mode, the user gets the chance to pick out which medical case they want to practice with.
Next up, we have case data referencing, where the system shall utilize predefined case data to generate a medically accurate mock oral examination.
In order to validate our case data referencing, we created a RAG pipeline log. As soon as a request is sent by the user, the pipeline log shows the token sent and the time it took for the request to execute.
Next requirement is speech-to-text conversation. Here, the system shall convert user verbal input into text and display the transcription.
Here's a quick clip where Daryl is demonstrating the speech-to-text functionality.
Acute non-perforated appendicitis.
The front end picks up his voice, converts it to text, and then it's sent off to the back end.
Lastly, text-to-audio conversation, where the system shall convert generated text into audio output and display the text on screen.
Here's a demonstration of the AI output being converted into audio.
An IV is established, and you begin administering fluids. The patient tolerates the IV placement well. What do you do next?
All right, next up we have timer, which says the system shall enforce a maximum duration of 7 minutes per case in accordance with board examination guidelines.
As soon as the examination starts, you see a timer in the top right corner counting down from 7 minutes.
For our 8th requirement, we have performance evaluation. The system shall grade mock examination results based on guidelines provided by examiners.
After the user completes a mock exam, they can navigate to the logging section and view their grading report. Here they can get specific feedback on what steps they missed and what they can do to improve next time.
Finally, we have data logging, which simply says the system shall log all conversations to a database for subsequent analysis and review.
Here on our dashboard screen, you can find a log of all the recent cases performed under the account. You can go ahead and click and view the entire transcript from the session.
We are calling our system the MOB, which stands for Mock Oral Boards. There are 4 primary components of our system, the first of which is the front-end UI. This element of the system is what the user sees displayed on their browser and allows them to interact with the rest of the application. As the user is conversing with the AI model, their messages get sent to the Fastify server, which is the first part of the backend. The Fastify server is responsible for coordinating the user's case creation and transmitting their responses to the RAG pipeline, which is the third element of the application. The RAG pipeline coordinates the user's responses and integrates them with case context, sending it to the AI model. And the AI model creates the response and then sends it all the way back through the application.
With the normal user's view being contained solely to the front end, there is an entire back-end retrieval augmented generation pipeline, which is also called a RAG pipeline, that does all the processing and can be considered the brains of the system. The backend takes in a user's query from the front end and enters it into our backend where it's processed and is given to the large language model to allow for the model to take that query and use the approved and verified sources as its base of truth to generate its responses.
Figuring out how to deploy our application to the cloud was another key engineering challenge that we encountered during the project. Ultimately, we decided to use Docker and AWS servers. In order to ensure that the code runs the same way on different environments, Docker places each component of the application into a container, and this container is guaranteed to always run the same way no matter which operating system it's placed on. That way, we can upload our application to the cloud and we'll know that it works out perfectly. Each of the 4 application components are placed into their own container, including the front end, the core backend, the RAG pipeline, as well as the database. On the right side, we have Nginx, which allows each of the Docker containers to communicate with one another.
An essential part of our project is the grading architecture. The grading architecture allows the examinee to have what they say automatically compared to guidelines that are given to us by our sponsor and our team of medical students. Simply put, the examinee will have what they said graded by the AI, and it will compare it to tiers. These different tiers will see if the step was a critical fail, if they missed it, if it was high priority, if it was helpful, if it was optional, or if it was unnecessary. All of these steps will be accrued into one value that will then show the examinee if they passed, if they failed, and also their clinical readiness that has been assessed by the AI as well.
Upon completing our major system requirements and testing with the medical team, we realized that our system design was limiting our ability to make changes and integrate feedback quickly. As the medical team used our system and tested case content, they would often think of a small change that might improve the overall case. The timeline for these changes to be deployed often took a number of days, and by that time the medical team had moved on to a new subject. To solve this, we created a new window in the UI allowing the medical team to directly edit the case data, save it, and then immediately resume testing. This additional change will have a strong impact on the future of the project, as it will allow the medical team and sponsors to continue developing the system after our engineering team steps away. Overall, we had a ton of fun and we're excited to see where the project goes next year.